Zero, negative, and rational exponents. Our objectives. At the end of this presentation, you should be able to apply the laws involving integral exponents and rational exponents, illustrate expressions with rational exponents, and simplify expressions with rational exponents. Let's start. What are rational numbers? Rational number can be made by dividing two integers. An integer is a number with no fractional part. Therefore, when we are talking about rational number, it can be a positive or a negative fraction. In conclusion, rational exponent is an exponent that is a fraction. Let's have a recall about the exponent. Exponent means the number of times we should multiply the base by itself. In this case, a is our base and our n is your exponent. When we are talking about rational exponent, the exponent are in fractions. What are the laws of integral? The laws of integral exponents also apply to rational exponents, provided that the roots indicated in the denominator exist. Let m and n be rational number, x and y be real numbers, variables, or algebraic expressions. The first law is multiplying exponent having the same base. In multiplying exponent having the same base, we'll just simply copy the base and add the exponents. Example, x squared times x cubed. Since we have the same base, which is x, we will just simply copy x and add the two given exponent. So we have 2 plus 3. So we have x raised to the 5th power. Applying it in rational exponents, we have 4 raised to 1 half times 4 raised to 1 third. As we notice, we have the same base. Therefore, we will just simply add 1 half and 1 third. Now, how do we add or subtract fractions? Take note of the similar and dissimilar fractions. So what will be the difference between the two? When we are talking similar fractions, these are fractions having the same denominator. Example, 1/4 and 3/4. So these are an example of similar fractions since the denominators are the same. Now, how do we add similar fractions? So in adding similar fractions, we will just simply copy the denominator and add the numerator. Same rule will be applied in subtracting fractions. So we have 1 plus 3, we have 4 over 4 plus 4 we have. Then copy 4. Then 4 over 4 is 1. For the similar fraction, example 1 half plus 1 third. Since the denominators are not the same, we will get the LCD of 2 and 3. How to get the LCD of 2 and 3? To get the LCD of 2 and 3, we will just simply write down the factors of 2 and 3. So we have 2, 4, 6, 8, 10, and so on. For the factors of 3, we have 3, 6, 9. So to get the LCD, look for the first pair which 2 and 3 had in common. So in this case, the first number is 6. Therefore, our LCD is 6. Next step is to divide the LCD to the original denominator of the given fraction and multiply it on the numerator. We will do it 1 by 1 by 1 half and 1 third. Therefore, 6 divided by 2 is 3 times 1 is 3. Then, we have plus. 6 divided by 3 is 2 times 1, we have 2. Then add the numerator. 3 plus 2, we have 5. And then copy the denominator, which is 6. Therefore, let's copy the base, which is 4. And the exponent now is 5 over 6. The second law is dividing an exponent having same base. So we have two rules. X raised to m over x raised to n is equal to x raised to m minus n if m is greater than n. So if their exponent on the numerator is greater than the exponent of the denominator, we will just simply copy the base and subtract the two given exponents. But if m is less than n, meaning the exponent of the numerator is less than to the exponent of the denominator, then we will be having 1 over x raised to n minus m. Example, x to the fifth power over x cubed. Since the numerator, the exponent of the numerator is greater than the denominator, we'll just simply copy the base, which is x, and subtract 5 minus 3. Therefore, subtracting 5 minus 3 will give us a difference of x squared. In this case, example, x squared over x to the fifth power. Since 5 is greater than 2 and 5 is in the denominator, therefore we'll be writing it as 1 over x raised to 5 minus 2. So we have 5 over x raised to the third power. Applying it, we have b squared over b raised to 1 half is equal to b squared minus 1 half is equal to b raised to 3 halves. The third law is two variables raised by an exponent. So in this case, the quantity xy raised to m, just simply distribute the exponent one by one to each of the variable. So we have x raised to m and y raised to m. Example, xy squared. Therefore, I will just simply distribute the exponent to one by x and y. So we have x squared and y squared. If there will be a number like 2a squared, so we will just simply distribute 2 or the exponent to each of the number and the variable. So we have 2 raised to 2 and a raised to 2. Then we will be simplifying this part since this is a numeric number. So we have 2 squared is 4 and copy the variable which is a squared. Applying it in rational exponent, we have the quantity 3a raised to 1 half. So we distribute 1 half 1 by 3 and a. So we have 3 raised to 1 half and a raised to 1 half. Fourth example, power by a power rule. So in this case, we will be multiplying an exponent by another exponent. Okay? So in this case, if an exponent raised by another exponent, we'll just simply copy the base and multiply the exponent. For example, x squared raised to 3. So we'll copy the base, which is x, and multiply the exponent, which are 2 and 3. So we have 2 times 3. Multiplying 2 by 3, we have 6. So we have x raised to the 6th power. Applying it in rational exponent, we have d raised to 5 raised to 1/3. So in this case, we will be just simply multiply 5 by 1/3. So multiplying 5 by 1/3 will give us a product of 5 over 3. But how? So remember, a whole number has a denominator of 1. Therefore, we'll just simply multiply the numerator by numerator and denominator by the denominator. So we have 5 times 1, we have 5 over 1 times 3, we have 3. Therefore, our answer is D raised to 5 over 3. Next, again, remember that fraction can be written as division. So how we divide two variables raised by an exponent? So in this case, again, we will just simply distribute the exponent 1 by 1 by x and y. Therefore, x raised to m and over y raised to m. So example, x over y squared. So let's distribute to 1 by 1 by x and y. So we have x squared and y squared. Applying it on rational exponents, we have 2 over x raised to 2/3. So again, we will distribute 2/3, 1 by 1 by 2, and x. So we have 2 raised to 2/3 all over x raised to 2/3. Number 6. X raised to 0 is equal to 1. Always remember, all variables, all numbers, all expressions raised by 0 will be equal to 1. Example, 1 million raised to 0 is equal to 1. 64a squared b cubed c to the fourth raised to 0 is equal to 1. Applying it in rational exponents, we have 4 raised to 1/3 times y raised to 1/2 raised to 0 is equal to 1. Number 7. X raised to negative m is equal to 1 over x raised to m. So this is an example of a negative exponent. So to make the negative exponent a positive exponent, just simply get the reciprocal of the base and then the exponent will become positive. Example, x raised to negative 4. So get the reciprocal of x. So remember, if the denominator is not visible, automatically the denominator is 1. Therefore, this will become 1 over x, then negative 4 will become positive 4. Applying it on rational exponents, we have 3 raised to negative 5 over 6 is equal to, get the reciprocal of 3, which is 1 over 3, and negative 5 over 6 will become positive 5 over 6. Next example is a fraction raised by a negative exponent. So same procedure to make the negative exponent a positive exponent, get the reciprocal of the given fraction. So we have the quantity x over y raised to negative m is equal to the quantity y over x raised to m. So example, 1/2 raised to negative 5. So therefore, get the reciprocal of 1/2. This will become 2 over 1 raised to 5, or simply 2 raised to 5. And 2 raised to 5 means 2 times 2 times 2 times 2 times 2. Okay, so we have 2 times 2, we have 4 times 2, 8, we have 2, 16, we have 2, we have 32. Another example is 3 over 4 raised to negative 3. So we have the reciprocal of 3/4, which is 4 over 3 raised to positive 3. Then distribute 1 by 1, 3 or cube by 4 and 3. So we have 4 cube over 3 cube. 4 cube is 4 times 4 we have 16, times 4, we have 64, over 3 times 3, 9 times 3, we have 27. Applying it on rational exponents, we have 2 thirds raised to negative 1 third. That will become 3 halves raised to 1 third is equal to 3 raised to 1 third all over 2 raised to 1 third. Thank you.